Hi everyone, we're going to get started in maybe a minute or so. So please go take the slides if you don't have a set. They're interleaved, so hopefully you'll get one set. It's about 10 pages in total, which has the two sets of lecture notes, one for our course organization, which I'll go over with you today, okay, and one for the set of slides that have to do with
How many pages are there supposed to be?
about 10. About 10 slides. Okay. Hello everyone, welcome to machine learning. My name is Min. I'm the lecturer for this course. It's easy to remember my name. You think of the minimum function and then you have me. Okay. How it works is just like the minimum function, if you send me lots of emails that have too many things all joined together, I'll just reply to one of them. Okay? So the best thing for you to do is if you want my attention, send me short bites of email. They'll all clog in my inbox and I'll be able to address them one by one. Okay? Fair enough. Okay, so we're going to go through the introduction. I hope you have had a chance to look at the website as well as Coursemology. I realize Luminous has a lot of problems, shall we say that? So some of you may not have been invited to to Coursemology. So I'll talk to you a bit about that in a little while. But first, let's talk about the introduction to machine learning. So why are we studying machine learning in the first place? Right? Maybe you're like, well, I hear it gives me great pay, right? Because you look at the jobs out there, many of them require some machine learning or statistics expertise. People who used to do this type of job function used to be known as statisticians, but now we have a sexier name. It's called data scientist or machine learning engineer, and the corresponding pay is a lot higher. So maybe you're thinking, okay, maybe I take this course, I can get a better placed internship, can get more money. Okay, not a bad idea, right? We all want some more cash. What else might we want to take this for? Because it's a popular course. It's over-enrolled, it's oversubscribed. No, really. Because teaching machines to learn is cool, right? We want to program, we have already learned how to do abstraction and software engineering. We want to put ourselves out of work, right? The whole premise of computer science is laziness, right? You've heard this before, right? We program things so we don't have to do them again, right? And when we can't actually program it well, we can do what humans do. We learn how to do a job function from examples, right? So you do internships, right? Somebody tells you, okay, well, this is the system, you have to use these functions and do this. And from examples, we learn how to do a job role, okay? So if you can't codify it into an algorithm, maybe we can have the algorithm write itself. Why not? Learn from examples. That is machine learning, right? Now, of course, we know everyone these days needs to understand machine learning. We hear about it constantly through Facebook, through Instagram, wherever else you consume your social media. Everyone wants to learn machine learning. There are lots of ways to learn machine learning. You've probably watched some videos on it at this point. Maybe you've read textbooks. Some of you may have some exposure to machine learning. How many of you have done some form of machine learning before? Don't be shy. Raise your hand. A couple of you? Okay. So if you haven't, don't worry. I know there's the level of expertise in this class may vary a little bit, okay, but we're going to try to normalize that over the course of this semester, of course, right? And so what we find now is society-wide, everyone needs to understand that, right? You hear in Singapore, there are lots of schools, and MOE is also thinking of introducing AI and machine learning into the curriculum for secondary, even primary school students are going to start coding. That's scary or what? Okay? But the point is, we need to understand what is machine learning first. How do we differentiate it from artificial intelligence, data science, right? What is this term? What does it mean? Okay? So we have to at least first understand it and then learn the principles behind it. Okay. Now it is very much the case that it is quite far-reaching and transformative. You have parents and they're worried about their jobs, about, for example, if you have siblings or parents in the transport industry, we know the transport industry is going to be completely disrupted by autonomous driving, right? So when that happens, what do we do with all of these people who haven't had the skills to transition to a new job? That's part of what I have to worry about as a lecturer in NUS, is about how do we upskill folks. Okay, you guys are lucky. You are called pre-professional education, okay, PET, educational training. So you haven't gotten your first job yet, so you can upskill now before you had the chance to settle in. Right, it's far-reaching and transformative in the sense that many different sectors of our world are transforming, right? So for example here, you can see it's even changing how people do research work, right? We can now machine read the scholarly publications that people are writing. Okay, that's some work that's done in my lab. Okay, we can re-engineer the social feeds that you get on Vine or Pinterest or TikTok or whatever. Okay, all of these systems that have to build news feeds for you need to recommend items that are created by friends or strangers. They need some way of recommending that, right? That's not done by a person, that's done by an algorithm. Usually one that's data-driven, like a machine learning system, right? And it even transforms our games, right? So if you play any StarCraft, Dota 2, or things like this, you've seen AI make tremendous advances, not on individual game playing, but a whole set of agents working together to win games over humans, right? So it's changing the way it's working. People in the AI and ML industry are trying to push the technology out there, create waves in social media, and also, in some unfortunate ways, scare the public. Okay, make the public worry that machines are going to take over their jobs. Now, machine learning and AI in general, we can think of as something that can transform the world, but it's also something that can potentially save us from ourselves, right? You've heard everywhere, people, except maybe in the US, all right? People everywhere believe that climate change is real, okay? And that we're going to destroy our environment, and the children that the next generation will have will not benefit from the world as we know it. Biodiversity will go down, water levels are rising, material costs are going up, energy costs are going up. Can we save ourselves from ourselves? Well, nowadays, engineering, manufacturing is so complex, right? Even in material science, there's so many range of materials that are possibly created with different types of properties. How can any one person, a scientist, create the materials that we need to save the future? Right? Maybe machine learning can help. Maybe machine learning can recommend the types of components, the types of chemistry needed to create new materials with new properties, less energy consumption, more efficiency. Okay, all of that is possible, right? So, for example, even the way we reduce pollution, or perhaps even, as we'll talk about in the very last lecture of the course, reduce bias, right? We have here in Singapore, we pride ourselves in being a diverse ecosystem of many ethnicities, but of course, Singapore is home to prejudice and racial stereotyping and bias too. Okay? Can we create systems that will help us engineer a more cohesive and diverse society that can benefit everyone? Now, it's true, if you want to have a machine learning background, it's very useful because corporates are all in. Microsoft, Google, Facebook, all of these different companies, people who graduate from my lab and all of our AI labs in NUS get very good job placements worldwide. I got a message this morning from my seniors alumnus who's now at Facebook in the US, previously at GIC in Singapore. He told me that he met another one of our alumni who's working as an advanced research scientist in Google. So these job placements from our school are real. Okay, you can benefit from them too. I mean, I was talking about postgrads. I have plenty of undergraduate, FYP, and UROPs, and people from this course, alumni of this course, who have great job placements here in Singapore and abroad. Okay, It's not just the MNCs that are looking for this, right? Singapore also provides a great ecosystem, one of the world's top for innovation, right? So startups worldwide, even in Singapore, are looking for talent. People who understand machine learning, the biases, the limitations, what it can do in order to propel the next stage of consumer growth. Right? We all lament, oh, if I had invested $200 in Apple or $150 in Bitcoin or whatever, okay, we'd be rich today. I tell you, at this very moment, in this semester, there will be companies whose valuations will be like those. Okay? You can be a part of that wave because the change in the paradigm of work, data is already here. Okay? So once you master this, go out and apply it. Okay? There are plenty of startups that are thinking of using AI for robots, but every part, right? Even, for example, Netflix, when you watch shows or you use Facebook or any other type of social media platform, we are using it constantly. You may not be even aware to you that algorithms that are learning from data are changing the way you do your life right now. So like I said, it's everywhere we look. Almost all of the platforms we use have some component in the sky, in the cloud. So if you use any of those utilities, if you're using local cloud service or Amazon web services, all of those things are based on machine learning for routing infrastructure, for placing services, for delivering services, for calculating information to deliver to consumers. All of that is there, right? It's getting even smaller and more compact. We can fit these systems onto Raspberry Pis or even smaller architectures that you can buy for the cost of your lunch, right? You can buy a circuit board for maybe 2 or 3 lunches in the canteen. You already have a system, has a USB port or a Bluetooth connection. You can implement machine learning there. But the bottleneck is this. There aren't so many people that understand it. Okay? It's not hard, like we'll do today, to turn on a Jupyter notebook, to press a button or two, to get a machine learning output, and then put on your resume. I'm a data scientist now. I pressed the button to execute a Jupyter notebook. Yes. So many people can put it on their resume, but very few people understand it. That is the bottleneck. That is why you are here. Okay? To understand machine learning, to be able to say, I can do more than press the button. I can do more than just write a couple lines of code that might be even auto-completed by an AI. Okay? I understand the limitations. I understand the biases, the inductive biases that happen from machine learning. So, you're here. Congratulations for getting through ModReg and EduRec. Okay, it's a new system. Everyone has problems with it. Okay. But there are some barriers. Okay, so now you got your registration for the course. Now you're trying to figure out your tutorial slots. Good luck with that. That's also a big mess. All right. But there are barriers within the course. All right. So for example, we have math. Right. So you need to know probability and statistics, linear algebra. Both of those are very key to understanding the foundations of machine learning. Okay? This is an interdisciplinary field. Okay? Machine learning was coined by people in the computer science and statistics, but it has roots from many different parts. Okay? Certainly, people in statistics were arguably doing machine learning way before people in computer science or then applied math were thinking about doing it. Okay? But you're taking this course in the School of Computing, not in the Department of Mathematics. Therefore, you must be able to program. Okay? So, what we're going to ask you to do is implement a lot of these machine learners as part of your ongoing continuous assessment. Okay? You're going to have to do it in Python. So those of you who are cross-faculty who've not really done much programming before, you have to do that. Don't worry, we will be here to help you. Okay? Maybe a little bit rough going at first. Okay? For those in SOC, our cohorts are getting stronger and stronger as evidenced by the rising, tide of good students coming in from Poly and JC, okay, and International Baccalaureate. But, you know, maybe you don't have a strong handle on math compared to your science or engineering colleagues, okay? You'll have to brush up on those, okay? And the way we're going to implement this course to make sure that things get delivered well, that you can watch it in your spare time, that you can speed me up at 2x if you want to, all right, is to watch our videos of the lectures through YouTube, okay? So YouTube has great services for video. I think you all know this, right? So you can put on auto captioning, you can speed your lecture up 3 times if you want, slow him down to quarter speed if you really like, okay? I wouldn't recommend it, but you could, right? So, and it's on demand, right? You can do it anytime, okay? I've seen many students watch videos at like 3 o'clock in the morning. That's still when I'm usually awake, so that's not a problem, okay? And we don't have to worry about the bang, 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 bang outside of the LT, right? So that will help us a little bit, okay? So what we're going to do is implement this through Flipped Classroom. In fact, we have already done all of the videos for the course from last year. They need some revamping, okay? But the material is already all there, okay? So we're going to be replacing some of the videos from last year. You'll see them go on, okay, as we work these out. So there are still a lot of changes like EduRec and ModRec for NUS. For this course, we're using a new content management system, learning management system. You guys have all experienced one way or another Luminous, right? The new IVLE if you were from NUS previously. But we're not going to use that system, as you probably know from talking to other people in the class or actually having been registered. We're going to be using another system called Coursemology. So I'll come to you, talk to you about that shortly. Okay, when I talk about Flipped Classroom, what is the schedule like for a particular topic? Okay, it goes a little bit like this, all right? Let's pretend we're in this particular week. Okay, where's my cursor? All right. So I'm going to start off here. Okay, so let's say I'm in week X, whatever week X is, like for example week 4. All right, and then in week 4 we have the topic of linear and logistic regression. So what will happen is by Wednesday night, you are going to have to watch the videos on YouTube that correspond to the pre-lecture material for that week. So there'll be week 4 pre-lectures, okay? So up to that point, you will have to actually do a pre-assessment that comes in Coursemology. I'll show you that in a little while, okay? Once you do the pre-assessment, you turn it in Coursemology, in the LMS directly at 11:59 at night, and then you're done for the first part, okay? So these will teach you the rough concepts of that particular topic in machine learning, okay? What will happen afterwards is 1 to 2 weeks later, depending on, but most of the time 1 week later, we will have our tutorials in the following week, okay? All of our tutorials are very nicely, because I begged and pleaded with our tutorial master, on Monday through Wednesday, okay? So Monday through Wednesday, you attend a 1-hour tutorial. Our tutorial leaders will go through with you on that topic, okay? Now, if after tutorial you're like, I completely don't get anything that's going on, okay? Or, you know, I'm sort of like weak on this stuff. I don't know how they step from this step to that step, okay? Then come back here, okay? Thursday at our normal lecture slot, I will be here, okay? Maybe a couple other people will be here, okay? It's completely optional. I expect 95% of you will not show up, okay? It's not meant to be something that we're kiasu about, okay? Let me just put it that way. I've seen some students, they come back and say, man, you guys are driving me crazy. I have to do tutorial, I have to do videos, I have to do videos, I have to do assessment, and I still have to show up at your lecture. No, okay? The lecture is optional. You watch the videos, okay? You come here, and then in the first hour of this lecture slot, I will try to go over the concepts again, okay? But on demand, that means from all of you sitting in the front rows, because I don't expect many of you, you can ask me questions. I will go over the slides with you. We can treat it as a mini tutorial, okay? But I don't want most of you here, okay? Because the whole point of flipped classroom is so you can do it at your leisure, okay? You can be virtual, you can do things as and when you wish, okay? So this is completely optional, okay? You can come here, all right? And then after that, after you go to the tutorial, there'll be a set of post-week lectures, so week 4 post lectures that will go over a bit more math, which will go over the mechanics of the particular information, okay? And those you will have to watch and complete the post-assessment, post-lecture assessment, okay? And you turn that in courseology, and then you're done for that week. Okay? Now, of course, these are interleaved. You don't have the luxury of just completing an entire topic and then go to the next topic. Every week there'll be a new topic introduced. That means you'll be in the pre-lecture week for one topic and the post-lecture week for another topic. Okay? Just like in tutorial anyways, right? Your tutorials are like that. Right? You get a lecture that week, and then the following week you get the tutorial on it. Okay? It's just that now you have a component that has to do with your CA that's stacked on that. Okay? Like I said, the health session is completely optional. It'll be here. It's only for certain weeks. Okay? Because, for example, this week you're here in class, week 1. Okay? Week 2, 3, 4, 5, 6, all the way until recess week. You're not supposed to be here unless you feel that you need help, okay? But if you need help, then you come to this session, and then I will be here to talk with you about it, okay? There will also be likely some faculty from psychology coming in to talk with you guys about the usage of flipped classroom and how to strategize for study for this class and other classes, okay? So even though you're in the machine learning class, you are actually data points too, okay? So you're providing us data to understand how to teach machine learning better, how to optimize how people study for materials in tertiary education, okay? So some of these studies will be carried on. They'll be carried only with your opt-in permission. Okay, so you can say, I would like to participate in the study. I don't want to. It's up to you. Okay, they don't affect your grade either way. Okay, so there's no extra marks for doing it. Although some of the psychological components that people are interested in testing may have a positive benefit to you. Okay. Of course, like in all cases, when we have any type of controlled experiment, there must be a hypothesis as well as a control condition. Okay, that means that even if you opt in, you may be assigned a control condition without your knowledge. Okay, now I've come to a part of the lecture that is also on the website, that is also in our flipped classroom video. Okay, so pardon me if you've already heard it. Watch the classroom videos already for course organization, but if not, I still need to go over it with you anyways because I need to make sure every one of you has heard this. Okay? So this is an important part about academic honesty. Alright? We are all adults in this classroom. Okay? And we're in the School of Computing, and digital information is very, very easily copyable. Alright? So you can copy all the assignments. And in fact, I'll ask you to copy in a little while, okay? But the whole point of class is to make sure you understand the concepts, right? So it becomes really, really important as an adult with certain responsibilities and rights, okay? To make sure you exercise your rights accordingly, okay? So in the group project, even on the homework assignments, which are in Google Colab and then the courseology assessments, you are completely allowed to talk with other people in the class, to your TAs, to me, okay? And you will be asked to write your collaborator's name on any assignments you do, okay? At the end of every courseology assessment, there's a part where you have to acknowledge any references that you looked at, okay? And where you think you have infringed on your right for getting full credit for the assignment, you tell us which parts of the assignment you did independently, and then we will give you the credits for it. Okay? So for example, I couldn't get, question number 5 and 6, but I needed the answer for 6 to get question 7. I took question 6 answer from my friend who's also in my tutorial group. Okay, fine. We won't give you question 6. We'll give you question 7. All right? You have to be fair to us. You have to be fair to your peers. One way we interact in this classroom is through a rule which I call Poki Marco. All right? And actually, it's based on a previous rule, Gilligan's Island's rule, but I think none of you have heard of Gilligan's Island. It's a very old sitcom from the 1960s. Okay? The whole point about this is that we want you to be able to reproduce the materials you learn from learning with others on your own. Okay? So what do, right? Go meet with your friends, discuss the solutions, whatever you want, okay? Write on a board, take notes on a file, in a Google Doc, okay? But afterwards, destroy all trace. What happens in Vegas stays in Vegas. Okay? After the meeting, do something else. Do whatever makes you not think. Okay, that's pretty easy these days, right? You just pick up your phone, oh, 2 hours gone. How the heck did that happen? Right? So you do that for at least 30 minutes. Okay? After you do that for 30 minutes, then go do the assignment. Okay? Then I trust whatever you put and discuss with others will be there. Okay? Now you might say, well, I put it in the trash, but I can recover from the trash, right? I can look at it again. Okay? Try to resist that, because what happens is you won't be learning from data. Right? You'll be copying from data, not learning. Okay? So that won't help you. You won't learn the concepts that you need. And ultimately, when you get to your midterm assessment or your final assessment, you won't be able to reproduce. You won't be able to generalize. Okay? So you'll be harming yourself, but also you'll be harming your peers. All of these people, all of you in the classroom, if you make your honest effort to do that, and somebody else cheats and gets in first place in front of you, everyone goes down a rank, right? Unfortunately, NUS is a curved society, right? So we have, unfortunately, to place this bell curve, okay? In part, I mean, we can argue, but for large classes where the law of large numbers hold, we have very little flexibility, okay? So please don't cheat, and if that happens, we will assess accordingly. So what happens when you cheat? Your assignment for that particular assignment goes to a 0, okay? Is that enough? No. Why? Because somebody who didn't do that assignment also learned a 0, but they didn't cheat. So what happens in your case? Your entire letter grade for the class gets rounded down. Okay? So you are going to get an A for the class. Congratulations, you've just made it to B. Okay? It's that simple. Okay? We need to be able to distinguish people who make an honest effort in the class, who aren't able to do the assignment but confess it on their own. I couldn't do the assignment and I just accepted 0. Okay? And those who would just, press a button to get the answer. Different. Okay. Now, how do we operationalize this class? Like I said, there's a pre-lecture and a post-lecture. What is in the middle is the tutorial session. Okay? Pre-lecture or pre-tutorial, we can think about it as above the hood. All right? When you drive a car, do you actually know what's happening inside the car? Well, of course you know, because you took secondary school. You know about internal combustion engines. Maybe you forgot a bit of it. Never mind. Okay? But in order to drive the car, you don't need to know all the mechanics. Okay? In order to do machine learning, you don't need to know all the mechanics. You need to know about the principles of machine learning. So above the hood, we'll be talking about that in the pre-video lectures. Okay? What's the big picture? How to run this algorithm in scikit-learn or Keras or wherever. Okay? To have hands-on exercises for you. And in certain cases, have connection with industry. So for example, after the midterm break, we'll have our midterm on week 7. Then we'll have a couple industry talks. Okay? And then you can ask us, to get help for mock job interviews. You're looking for a data science job. Perhaps you want, our staff to give you some questions so that you can be prepared for that type of thing. Okay? Below the hood, that's where the post-lecture information comes. Okay? So you get some of this treatment during the tutorials, okay? Other parts of it will be through the videos, but this will be all the math, okay? All the gory math details, all the proofs, etc. Okay? The math is really, really important for mastery, okay? To understand the concepts of why learning is hard and why it's feasible, okay? And to ground it insight, okay? But, you know, I actually don't care so much whether you remember this 10 years down the road, okay? What I want is that you can do data science, you can do machine learning, you understand the biases incurred by each of these algorithms, okay? So the big picture, that means the pre-lecture videos are more important, okay? But of course, for detail and for examination, we have to grill you on specifics, okay? So that will be below the hood, okay? So when you come to the end of this course, when you fill out the course feedback, when you're trying to get your grades over the SMS system, okay, you need to fill out something that asks yourself these 4 questions. Did you get from this course an understanding of the basic concepts of machine learning? Are you able to apply an appropriate machine learning algorithm given a problem? Are you able to evaluate the performance of a machine learning algorithm after you've applied it? And can you do a machine learning experiment using machine learning tools? Okay? These are the 4 top-level learning outcomes that we want you to be able to master as a part of taking this course. Okay? Keep that in mind. Now, for those of you who have already gotten some machine learning background, and you've already tinkered with deep learning and you have a good grasp of probability of linear algebra, I invite you to take a DYC, or do-it-yourself module that I have constructed with the help of some undergraduates and postgraduates. It's called Deep Unsupervised Learning. It's meant for graduate students, okay? But I know there are always some undergraduates who are ready for this challenge, okay? So if that happens to speak to you, you can come to talk to me, or you can just Google Deep Unsupervised Learning NUS. You will find this webpage. You can enroll for this course. We have faculty, we have students and staff, we have people from all places. We even have high school students that come and take this course, okay? So, separately from that, I want to tell you about the programming methodologies that we're using in this course, okay? So actually this is not quite right. I think this is incorrect. This should be 3.7x. I think we're on 3.7. It won't matter anyways. We're doing whatever that's implemented in Coursemology or in Google Colab, okay? So you'll be learning the Python programming language. How many of people do not know Python? A couple? Okay, don't be shy. Okay, so several of us don't know Python. That's okay. It's an extremely nice language. Okay, I think most of our peers have learned it, and they'll tell you it's probably the nicest language they've met. Okay, because it incorporates a lot of very good features. Okay, how many people have used Jupyter Notebook? Okay, a handful of you. You all will be able to raise your hand by the end of today. Okay, Jupyter Notebook is a online system as well as something that you can install on your laptop to run a couple different programming languages, Python in particular, in a nice scaffolded, user-friendly version way. Okay, now how many of you have used Google Colab? Okay, a few. Okay. Google Colab is built on top of Jupyter Notebook. Okay? It's Google's own version of Jupyter Notebook in a cloud setting that allows us to use it without needing to fiddle with setups. Now, how many of you have a Gmail or Google account? Come on, that should be everyone, right? Okay. Give me a break. If you're not on Google, there's something wrong with you if you're in the computer science community. Okay? Okay, so you have a Google account. I'm just going to assume that you do because we're going to do all of our exercises using Python stacked on top of Jupyter Notebook, stacked on top of Google Colab. Okay, to do that, it's very simple. You just go to Google Drive and then you're there. Okay, so will be able to take advantage of all of that infrastructure, and you get free, big, nice dots on your resume. Google Colab, Python, Jupyter Notebook. Okay? See, I told you you're a data scientist. Okay, so this is what I want you to do. Click on this URL. If you're taking the ones from the class notebook, which you have a PDF on, okay, beware the PDF link. I updated the text without updating the underlying hyperlink, so make sure you type this in, okay? So I'm going to do that. Let's see. Okay, I need to get out of this. Look.